Hey, it's Dan. I'm glad you came here to get some math help. Let me ask you to do something before we watch the video. Please subscribe and like this video. Let's do the math. Let's talk about how to simplify cube root like this beast here. So the first thing I want to do is simplify the cube root of 192. And I used my calculator and divided it by 3 and realized that 3 times 64 is 192. So you can divide it by 2, you can divide it by 3, you can divide it by different numbers. It doesn't really matter, but you need 2 factors that multiply to be 192. I'm choosing 64 and 3. If you do that, 64 breaks down to 16 times 4, and I still have the 3 there, and then 16 is 4 times 4. So I've broken this down until I have 3 of a kind. And I'm not going to break the 4 into 2s because I already have 3 of a kind here. So the cube root of 192 is going to be 4 times the cube root of 3. So 4 times the cube root of 3. So keep that in mind. We've got 3 4s here, and that's as far as we need to go. Now, one way to do this is to write out 4 x's like this, and 6 y's like that, and 2 z's, and 9 q's, or excuse me, 7 q's like that. And since it's a cube root, we're looking for 3 of a kind. So if I mark through this, I could circle some of these. Like I could circle here and say that's 3 of a kind there with 1 left over. Here I have a couple of different sets of 3 of a kind here. So I have these, 1, and then another one there. I'm trying to video and circle at the same time. So that's 2 different sets of y's. I don't even have 3 of a kind on the z's. Now for the q's, I do have 3 of a kind there and 3 of a kind there with one left over. So we circle those because we're going to use that to formulate our final answer over here. So from this, I have 3 4s, so that 4 is going to come on the outside, and then I have a 3 left over, so that's what I have underneath there. So I have 4 times the cube root of 3, just in terms of the numerical part. Now, in terms of the variables, what I'm going to do is I'm going to say, well, I had one set of 3 here, so that's x to the first power, and then there was an x that was left over, so that goes underneath the radical. Here I had 6 y's, but that's 3 of a kind there, 3 of a kind there. So I have 2 sets of y's, so that's y squared. And I didn't have any left over, so that's why I don't have any under there. And then for the z's, I don't even have 3 of a kind, so all of those are going to go under the radical, z squared. And then with the q's, I had a set of 3 here and a set of 3 here, so that's 2 sets of 3 with 1 left over. So 2 sets of q's with 1 left over. So that's my final answer. Now there is another way to think about this. I think this is a nice concrete way of seeing the pairs of 3 with a cube root. But the alternative way to do it is to divide. 3 goes into 4 one time with 1 left over. So I'm just dividing. 3 goes into 4 one time, so that's x to the first there, but there's 1 remainder, so the remainder goes underneath the radical. 3 goes into 6 2 times, so y squared, and none left over, so I don't have a y under there. 3 will not even go into 2, so I don't have any z's here. They're all under there. And 3 goes into 7 2 times, so q squared with 1 left over. So it looks like that. So that's an alternative way of doing it just by dividing. This way provides a concrete way of looking at the variables. Anyway, so that's a fairly difficult cube root to simplify.